I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we'll discuss about time and capacity. We have taken a very unique example, hard to see these days, but age-old methods of farming. It'll be very interesting to see how do we connect that with time and capacity. So when I say time, we'll consider time in seconds, minutes, and hours. We will see how to convert between these units. And when I say capacity, in that case, we'll look into volume of water, right? So we'll consider volume of water. We'll use two units in this case. One will be liters and the other will be gallons. And we see how these things are connected, right? So I'll just show you a video on ox-drawn water wheel application. I'd like you to watch the video carefully, since you need to describe the situation. Also record the time for one revolution. What I mean to say is, once full circle, this ox-drawn water wheel is rotated. Based on this, we'll have 10 questions, and I hope you'll find it very interesting and useful. So now, let's actually watch the video. I hope you enjoyed this clip, which was less than a minute. And I will now like you to describe the situation. So take your time. You can actually write your notes on what really happened, what was going on, and why do we use this kind of an application. Also, I hope you also recorded time for one revolution. That is a key parameter, as that is going to help us understand the solution to many questions which are coming. So part A of question number 1 is, describe the situation in your own words. Well, if you are there in a classroom setting, you can share your description with your friends and then move on to question number 1B. Question number 1B is, which of the following connects with this situation? A, animal abuse. B, poverty. C, irrigation. D, pleasure. Take your time and let me know. Yeah, what do you say? Well, most of you are correct. It is definitely irrigation. So since last thousands of years, this practice has been there for irrigation, where a pair of ox will go around, and in that rotation is translated to the vertical rotation here, where you have the water buckets, and they will pull the water out of the well, and the water goes into the fields with the canal system. It is a very efficient way of working. Now let's move on and see what is there for activity number 2. Activity number 2 is, you need to figure out the time for one revolution. So I think if you don't remember how much time it took for one full revolution, it's worth watching the video again. So when you watch the video this time, try to estimate the time taken for one complete revolution, right? So in which the ox drawn water wheel rotates one full circle. Is that okay? So that is what you have to note. And once you do that, then we have your question number 2 here, which is what was the time for one complete revolution? So you can write down one of these, select one of these. Again, if you're in a class setting, you can make a table and see what most students are saying about the cycle of a revolution, right? And then we can work further with the most common answer. So let's watch the video once again, and then we'll move further. So I hope you're ready with your answer. So what do you get? What was the time for one complete revolution? Well, let me take C as your correct answer, 30 seconds, right? I hope most of you got around that part, right? So we'll take 30 seconds for one complete revolution and then move forward. The next example for us is Activity 3. We need to convert units from seconds to minutes, right? Now here, there are 60 seconds in a minute. I hope you know that, right? So in a minute, there are 60 seconds. So that is a known fact. Just a reminder, which I've written here in the box. 1 minute equals to 60 seconds. Based on this, you need to answer question number 3. Let us assume that one revolution took 30 seconds. We are assuming that one revolution took 30 seconds. How many minutes did it take for one revolution? You can pause the video, answer the question. So one revolution, let's write down. So one revolution took 30 seconds. We have to write this answer in minutes. 1 minute is 60 seconds, right? So now you know that as far as one revolution is concerned, it took half a minute, right? 30 is half of 60. So we can say one revolution took half minute. So we get our option, which is D as the correct option, 0.5 minutes or half a minute. You can also say that in this particular case, in 1 minute, we have 2 revolutions. Just to avoid this term half, 1 revolution, half a minute, 1 minute, 2 revolutions. So you'll see in many examples, 1 revolution, 1 minute, 2 revolutions will help rather than 1 revolution in half a minute. So half makes things very difficult to work at times. With that in mind, let's move forward and take the next example. Activity 4. We'll now convert seconds to minutes, and you know 1 minute is 60 seconds. Now here is the information for you, which is there are 60 seconds in a minute, right? Now the question number 4 here is, one revolution took 30 seconds, right? This is what we assumed. How many revolutions in 5 minutes? So you can answer this question One revolution took 30 seconds. How many revolutions in 5 minutes? So we could also see this as in 1 minute, there were 2 revolutions, correct? And in 5 minutes, there were 2 times 5, which is 10 revolutions. Is that clear to you? Do you see how that half a minute thing and 1 minute 2 revolution helps, correct? So it is kind of important to sometimes rearrange your numbers. We are saying 1 revolution in 30 seconds, which is half a minute. Instead of that, if I say 1 minute 2 revolution, that is correct, yes? But that makes our calculations very simple. And so we get our answer, which is 10 revolutions in 5 minutes. So the number of revolutions are twice the number of minutes. Perfect. Let's move on and take the next example, question number 5. Here, we'll just practice conversion of time units from minutes to seconds. I'd like you to pause the video, complete this table, and then we are going to discuss. As you know, 1 minute has 60 seconds. Keep that in mind and then do the conversion. So when you go from minutes to seconds, you need to multiply by 60, correct? So 2 times 60 is 120. Similarly, when you go from here, you will have to multiply by 60. Now 10 will give you 600 and half of 60 is 30. So your answer should be 630. Does make sense, right? So you could think like this. It is 10 times 60, which is 600, and 0.5, which is half, times 60 is 30. And when you add that, you get 630. Is that clear? So in this case, we used half as a better way of doing it, right? It's kind of half of 60 is 30. Perfect. So we may interchange half and 0.5. So half is rather better than 0.5 at times to work with. Is that clear to you, right? Now let's do the reverse calculation, which is if we know the seconds and we want to know how many minutes, in that case, what should you do? We have to get a smaller number, right? So when you want smaller number, you have to divide. So we'll divide by 60 in both the cases and get our answer. So when you divide, you could do like this. 300 divided by 60. So 0 and 0 will cancel, right? And this 6 goes 5 times. So you get 5 minutes. Now when you have 630, let's do this also. 630 divided by 60. Do you see this method? Cancel zeros. It is as good as dividing by 10, right? As good as dividing by 10. So, sorry, this was 3600 which you want to do. Sorry. We have to do this one. 3600. Let me redo. So we have 3600. We have to divide this by 60. So when you divide, you can cancel this 0 and then divide by 6. So it gives you 6 times 6 and 1 0, 60. So we get here 60 as our answer. So 3600 seconds is 60 minutes. So that is how you can complete your table. So I hope the concept is absolutely clear. Right? Let's move on and look into hours now. So you know that in our case, it takes 30 seconds to make one revolution for this particular wheel, right? Which is actually drawing water in this direction. So it takes 30 seconds to complete one revolution. We also see it in another way, and that is, let me write down, in 1 minute, we get 2 revolutions. Right. So we can look at the statement in this fashion. Now, 30 seconds is half a minute, 1 hour is 60 minutes. You know it. Question number 6 here is, how many revolutions will there be in an hour? So pause the video, answer the question. So when we say 1 hour, we really mean 60 minutes. And since we know in 1 minute there are 2 times, so as far as the revolutions are concerned, we have to multiply this by 2, double, 120. So we get 120 revolutions, which is the option A. Does make sense to you? Perfect. So in our example, we have 2 revolutions in a minute, and in an hour, we have 120 revolutions. We are going to use this information as we move along. Do you see how, from this age-old technique, we have learned so much about time in seconds, minutes, and hours? So let's move forward and see what happens next. Activity 7. Again, the same information is given to you, which is it takes 30 seconds to make one revolution, right? Which is kind of same as we did in the last activity. But the question here is, farmer worked from 6 a.m. to 7:30 a.m. Right? So he worked from 6 a.m. to 7:30 a.m. Find the maximum number of revolutions possible during this time. So we'll assume without rest, right? So without rest. Continuously, you'll get the maximum number of revolutions. Now, when I say from 6 a.m. to 7:30, how much time is that? Well, 1 hour and half hour. So 1.5 hours, right? So we have 1.5 hours here, which turns out to be 90 minutes. Perfect. Since 1 hour equals to 30 minutes, 60 minutes, 60 minutes, and half of that is 30. So when you add that, you get 90. Clear? What do we need to figure out? We want to know maximum number of revolutions. So clearly, in our case, we'll just multiply this minutes by 2 and get 180 as our answer, right? Since when we say it takes 30 seconds for 30 seconds for one revolution means 60 seconds for 2 or 1 minute for 2, right? So 90 minutes into 2, 180. So our answer here is D. Is that clear to you? So again, you see how it helps to think that in 1 minute, we are having 2 revolutions. Clear? Let's move on and take the next example. So we have already looked into seconds, minutes, and hours. At this stage, we are moving on to the water part of this cycle. We'll see how much water is being drawn in liters. So activity 8 is working with time and volume. Okay, the information given to you is it takes 30 seconds to make one revolution. In 60 seconds, there will be 2 revolutions. That means in 1 minute, there will be 2 revolutions. Correct? So that's a good information again. 60 seconds is 1 minute, 1 hour is 60 minutes. Question number 8. In one revolution, 100 liters of water is drawn into the fields. In an hour, how much water will be drawn for irrigation? That's your question, right? So it's very interesting to see that when you're working here, So this is what is rotating, and when that rotates, the water is falling from here, right? So this wheel is rotating, and then you get water, and this water flows into the fields. So that is how the system works, right? And we are saying in one revolution, 200 liters of water is drawn into the field. So in an hour, how much water will be drawn? That is what you need to figure out. Perfect. So now, once again, 1 hour is how much? 60 minutes, right? Now 60 minutes is twice 120 revolutions. We know that. Now we are saying one revolution 200 liters. So we have to multiply this by 200 to get amount in liters. So when you multiply, you get 3 zeros, right? 1, 2, 3 zeros. 12 times 2 is 24. So when you do that, let me write down and show you how we get our answer. So we get 120 times 200, which is these 3 zeros, right? And then 2 times 12, which is 24. So 24,000 liters, huge amount, which is our option A. You get the idea. So that is how we figure out how much volume of water is being taken out from the well in this particular case. So it looks like a simple operation. However, it is very efficient operation. No electricity, no pollution. You see that? No electricity, no pollution. It is all natural. Now let's look into the next video. I hope this concept is clear to you. So one revolution gives you 200 liters, and we have 120 revolutions. So we'll multiply 120 by 200 to get our answer, which is 24,000 liters. Now remember, approximately we have 1 gallon is actually 3.7 liters, but we'll approximate this value to 4 liters for our work, right? And then do calculations in gallons, since the units, 24,000 liters, right? So it is around 6,000 gallons, right? So that is the amount of water. Let's look into the next part. Activity 9 is working with time and also volume, right? And volume. The information given to us here is 1 revolution per minute. It remains same as it was. 1 hour is 60 minutes. 1 revolution gives 50 gallons of water. So we're now talking about gallons of water. Do you see that? So we are saying 1 revolution gives 50 gallons. So earlier it was 200 liters. Do you see that? 200 liters. And now we are saying 50 gallons. So 200 liters is approximately equal to 50 gallons. Is that clear to you? 4 times, right? If you do this times 4, you can say times 4. Is it clear? Gallons is a huge unit. Now, because there's too much of water coming out in the system, we are switching over to gallons. Now the question is, there are 2 revolutions in a minute, right? In 1 revolution, 50 gallons of water is drawn into the fields. How much water will be drawn for irrigation in an hour? So we have to write answer in gallons now, okay? In an hour. So 1 hour means 60 minutes, and that means 120 revolutions. And in each, we have 50 gallons. So we'll multiply this by 50 to get the answer in gallons. Clear? So 0, 0, 2 zeros. 5 times 2 is 10, 1, 5, 1 and 5, 1, 6. 6,000 gallons. So which is option A. Is that clear to you? See how easy the calculation becomes. Perfect. So I hope you got the same answer. We are now almost at the end of this video. Activity number 10. Take this as an assignment. It is summary of all what we did today in this video. Right? So we'll begin with our basic information, which is 2 revolutions per minute, right? So the number of revolutions per minute is 2. 2 revolutions per minute. You know the conversion, and we also know that 1 revolution gives 50 gallons of water, right? So the gallons of water, this is the water which is dripping as that wheel rotates. Do you see that part, right? So because of this rotation here, they are connected with the shaft. And so the water, these are the buckets that goes into the field, right? So question number 10 here is, thanks to all the farmers who have worked day and night to get the food on our plate, 1 acre of field needs 24,000 gallons of water per week, right? So this is important information. The information here is that 1 acre of field needs 24,000 gallons of water per week. Okay? How many hours per week should the ox water wheel run? So we need to now figure out that weekly, how many circles or revolutions should it go through? Assuming that there is 1 acre of field, right? So we are saying 1 acre of field needs 24,000 gallons of water. Gallons, right? Not liters. How many hours per week should the ox water wheel run? So I'd like you to pause the video, do your calculations, go back and forth in this video, understand the situation, and then you may write your answer in the comments. Is that clear to you, right? So I will reply to your answers. I hope you enjoyed this journey along with me in understanding how irrigation has evolved over a period of time. We don't see the system at present. However, many places in India and in Egypt and Africa, still we have this system. It is indeed a very efficient system, mainly because it doesn't create pollution, right? I hope you understand and appreciate the techniques adopted by our farmers to bring the food on our plate. Thanking them once again, I'm closing this video. I will appreciate if you could take out some time and provide ratings to this particular video. You can rate it from 1 to 10, where 10 is the best. Also, feel free to provide your suggestions. Thanks for your time and all the best.